We are going to be looking at some logic and reasoning here. First definition for this part is a conjecture. A conjecture is an unproven statement that is based on observation. So pretty much you haven't proved something, you've just watched it happen, and you make a conjecture about it, so you make a statement about something that you've seen. For a conjecture to be true, it must be true for all cases, and for a conjecture to be false, you must just find one counterexample. So a counterexample is a situation where your statement is false. So if you say, I don't know, maybe you notice that every time you walk into my room, the projector's on. So you make a conjecture that every time you walk into Mrs. Geyer's room, the projector's on. Well, for that to be true, then every single day from now to eternity, you have to walk into this room and the projector has to be on. For that to be false, if you walk in on a random Wednesday and the projector's off, then the conjecture is false, and that situation is a counterexample. But we tend to deal with it more with like math terms. So again, a counterexample is a specific case for which a conjecture is false. Conjectures tend to happen when we use our inductive reasoning skills. This is when you find a pattern in specific cases and then write a conjecture for a general case. So it uses a specific example. So maybe you notice something occurring over and over again, like my projector is always on, right? So you write a conjecture about it. But then there's also a type of reasoning called deductive reasoning, and this is more scientific. So deductive reasoning uses facts, definitions, properties, and laws of logic to form a logical argument. So this, we're not just seeing something happen, right? There is a basis for it. Maybe a mathematical rule or a scientific definition, right? Or a theorem or a law of some sort. So it's a little more scientific, a little bit more solid. You're not just like seeing something happen. So first we're going to describe patterns. This is using our inductive reasoning skills. So this says describe the pattern, then write or draw the next two numbers or letters. So we have the pattern 2, 5, 11, 23, 47. You need to discern what the pattern is, figure out what the next two numbers are, and then explain it. So if you take a look, we're going 2 to 5. Well, to get from 2 to 5, you could say, okay, well, maybe I'm adding 3. But from 5 to 11, you're not adding 3, right? There's a bigger difference there at 6. So you have to kind of take a look, think about your numbers, and what you're actually doing is you're taking the previous number times 2 and adding 1. 2 times 2 is 4, plus 1 is 5. 5 times 2 is 10, plus 1 is 11. 11 times 2 is 22, plus 1 is 23, and so on. So if I take 44 times 2, that's going to give me 90. If I take 47 times 2, that's going to give me 94, plus 1 is 95. So the next number in my pattern would be 95. Then if I do the same thing with that, times 2 plus 1 would give me 191. So my pattern here is the previous number times 2 and add 1. Then for the next part, we're looking at letters, A, Z, B, Y, C. This, we're kind of like bouncing back and forth in our alphabet, right? First letter, last letter. Second letter, second to last letter. So third letter, it'd be third to last letter, which is X, and then we would go our fourth letter, which is D. And there's a few different ways to describe this. The best way I've kind of thought of is you're almost going, you're descending and ascending in alphabetical order, right? Or you're jumping back and forth between the alphabet. How you want to describe that is up to you. So we would say descending and ascending alphabetical order. Right. Then finding a counterexample. So it says find a counterexample to show the following conjectures are false. You can either give a picture or a written explanation. So this is saying, tell me one situation where this does not work. It says the value of x squared is always greater than the value of x. Now, what sometimes people confuse is they take this statement and they rewrite it. I don't want you to rewrite the statement. The statement is what it is. I want you to show me that this statement is false. The value of x squared is always greater than the value of x. Show me a situation where a number squared is not greater than that original number. This can happen in a few situations. For example, what if x was 1? So I'm just going to kind of give a mathematical explanation here. So x is 1, right? And if x is 1, that means 1 squared is also 1. And 1 is not greater than 1. So if you put your greater than sign and put a slash through it, that wouldn't work. Or write it out. If x equals 1, then 1 squared equals 1, and 1 is not greater than 1. You could also do that with 0. That would work. You could also do that with fractions. So there's a few different ways that you could make that work. The sum of two numbers is always greater than their difference. So don't rewrite the statement. Show me a situation where you add two numbers and it doesn't end up being greater than if you subtract them. So I'm going to show you two different examples here. Let's say I took a negative and a positive number and I added them, like 2 plus a negative 3. I'm allowed to add those. And if I add those, I end up with negative 1. Okay, well, what if I subtracted those same numbers? That would give me 2 minus the negative 3. Well, that's going to, you remember your double negative, right, turns into addition. That's going to become 5. Well, here's a situation where I added, I got negative 1. I subtracted, I got 5. That shows this is not always the case. My sum was not greater than my difference. So I would say negative 1 is not greater than 5. And that would be a counterexample. If negatives and positives confuse you, think about 1 and 0. If you take 1 plus 0, that's just going to give you 1. But if you take 1 minus 0, that's still just going to give you 1. And 1 is not greater than itself. So that would be a counterexample. If you have questions about these, let me know. People sometimes struggle with that concept. And then last thing, comparing inductive and deductive reasoning. Decide whether inductive or deductive reasoning is used to reach the conclusion and explain. The answer to the last 10 problems on your test was B. So the next problem's answer will also be B. Well, so you have to decide, is it inductive or deductive? Is that based on a pattern, or is that a fact, definition, property, or law? Well, key thing is you're just saying, well, the last 10 problems were B. So I think the next one's going to be B as well. You've observed a pattern. So this is inductive reasoning. And we're going to say because a pattern was observed. And then number 5, the sum of two positive numbers is always positive. Since 9 and 12 are positive numbers, their sum will also be positive. Well, this is a fact. If you add two positive numbers, it is always going to be positive. So this is a mathematical fact. So this is deductive reasoning. And that is because this is a mathematical fact. Okay. So that's it for the 2.1 notes. Let me know if you have any questions.